I'd like to introduce the speakers. Phil Comeau, who's going to be participating in today's presentation in a support role. For those of you that do not know, Phil is a professor emeritus at the University of Alberta. He was a professor of silviculture and stand dynamics at the U of A from 2000 to 2017. Phil has conducted research relating to competition dynamics, competition management, mixed wood management, silviculture, silvicultural systems, growth and yield systems in Western Canada. He has been the chair of the Western Boreal Growth and Yield Association, West Bogie, project team since 2003, and has worked with the continued development of the mixed wood growth model. He was the recipient of the Canadian Institute of Forestry's Tree of Life Award for the Rocky Mountain section in 2014, as well as the CIF Scientific Achievement Award in 2016. So welcome, Phil. The featured speaker for today's talk is Ivan Bjelanovic. Ivan's involvement in this project has been in the role of research assistant at the University of Alberta. At the U of A, Ivan worked on several projects within the Forest Stand Dynamic Research Group, developed tools to predict ecosite-based forest productivity, in addition to evaluating several silvicultural trials. Ivan has completed his master's degree in forest biology and management at the U of A under the supervision of Phil, and he holds a bachelor's degree in forestry from the University of Belgrade in Serbia. Currently, Ivan's working with the Canadian Forest Service on the design and development of the wildland fire risk web application. And I am going to now turn the floor over to Ivan for his presentation. Welcome, Ivan. Looking forward to your talk today.
Okay, thanks, Brian, for the kind introduction. Yeah, hello, and hope everyone is holding well during this cold Arctic weather. And good news here in Edmonton is coming some warming over the weekend, so we might enjoy some nice weather finally over the weekend. So as Brian mentioned, in this webinar, we will present results from the first 8 years of Dynamic Aspen Density Experiment. Interestingly, that period was long enough to observe some significant growth responses to thinning, but also to have very interesting findings in terms of growth and yield projections. So therefore, we set today's presentation under the title "Precommercial Thinning in Boreal Mixedwoods Increases Spruce Yields." So I will be presenting the results today. I worked on this analysis together with Professor Phil Comeau. So we also wrote the manuscript, which is now about ready to be submitted for publication. And we will be, as already mentioned, we'll be available for questions and comments after the presentation. And also you can see our emails for any comment or feedback. So regarding this study, first question comes up is why mixedwood? In Western Boreal Forest of Canada, species composition ranges from deciduous dominated through aspen spruce mixes to coniferous dominated, which also varies in terms of the stand age, the successional stage of stand development, and other factors, of course, particularly in central mixedwood natural subregion, that is the dominant forest type. So while the mixedwood stands of aspen and spruce are important economically, as their main commercial tree species are providing wood fiber supply, there are numerous benefits from managing mixedwoods ecologically as well. So first of all, biodiversity is higher in mixedwoods than in single species boreal forests. In addition, mixedwoods are more productive and can achieve a higher stocking than pure stands of these species due to differences in growth rate and shade tolerance of the two species. Growing spruce with aspen may also improve spruce wood quality, can also reduce impact on terminal leader, damage from weevil and other insects, can reduce competition from understory vegetation, reduce frost injury, also reduce risk from wildfire comparing to pure coniferous forests. So in summary, why mixedwood, we can say mixedwoods are more resilient than pure stands, and mixture carry less risk in terms of sustainable forest management. So now pre-commercial thinnings in young mixedwood stands, while we can see, we know all these benefits from the managing mixedwoods. At the same time, aspen overtops spruce during the first 50 to 100 years of stand development and seriously impact spruce growth. Pre-commercial thinning also can, as a silvicultural tool, can lead to increased spruce growth as well as improving size and yield of aspen at, at rotation. So pre-commercial thinning may also, as some recent studies shows, may also increase the resilience, resistant of these mixed stands to drought as well. So in order to address all these hypotheses regarding the Boreal mixedwood and the pre-commercial thinnings, Dynamic Aspen Density Experiment was initiated back in 2008 and today is managed by FGrOW. So main purpose of this study was to examine that relationship between the different aspen densities and how they impact white spruce growth. So main objectives for these studies are to examine effects of aspen density on stand development, then to examine effects of aspen density on survival and growth of white spruce, and finally to evaluate the impacts of optimizing white spruce survival and growth on hardwood production, or in other words, we can say how much do we need to sacrifice of aspen in order to gain spruce volume increases in those mixed stands. So study design, there are 7 installations established in 17-year-old stands, and there are also 7 installations established in 5 years old older stands. That's actually 22 years old stands as well. So, and in order to select sites for this study, there are some certain criteria used. First, for spruce, it was targeted planted spruce after clear cut with around 1,000 stems per hectare at the time of treatment establishment. Then natural aspen density was desired, which is at that age around at least 6,000 to 10,000 stems per hectare at the time of the experiment establishment, and that there was no delay in between harvesting and planting, that there was no further silvicultural treatments until experiment was established as well. So in terms of thinning treatments, aspen density was set at five levels. First treatment was zero aspen. Actually, all aspen was clear and pure spruce was created. Then next treatment is heavy thinning, reducing aspen to 1,000 stems per hectare. Then next is 2,500 stems per hectare treatment. Next is 5,000, and also control plot, or actually natural aspen density unthinned stand was included as well. So spruce was treated if necessary as well in order to achieve those desired spacing and reduce spruce to spruce competition in case of some clumpiness or double planted spruce, etc. So finally, the study design for this included 5 treatments per installation times 14 installations. 70 PSP plots was available for this study, and the study design was randomized block design within each installation. So here's location of the sites. They are all located across central mixed natural subregion, and therefore they are in similar climate and ecological conditions. We also checked the ecosite from provincial map, derived ecosite phase product, and we found that they're all situated in ecosite D, as low bush cranberry, and in terms of soil characteristics, that's they're all in a mesic soil moisture regime and a medium soil nutrient regime. So measurements available for this study, and First, at the establishment year, we have two type of measurements. So first pre-treatment measurements, and then temporary circular 10 square meters plots. 4 plots were established at each sample plot at the corner post of 10 by 10 square center, the plot center. So that was pre-treatment. That post-treatment measurements included the treatment unit, which is 50 by 50 meters, then main PSP plot 20 by 20, and deciduous subplot for deciduous saplings measurements 10 by 10. So that was for post-treatment measurement. Measurement 1 was done at the establishment year. Then measurement 2 was 3 years later, and measurement 3 was 5 years after the measurement 2. Just to make note that 3 installations have not reached yet the age to be remeasured for the second time. So we were missing those 3 installations in our analysis for the latest measurement. And then for all post-treatment measurements, tagging limit was breast height, so for both spruce and deciduous. And another important issue here was to solve about the spruce origin. So we found at most of the sample plots, we found the natural origin, spruce origin, and we found substantial variability in abundance of those natural origin spruce. However, we also confirmed that natural origin spruce was clearly in lower size class, right, in terms of dBH and height than planted spruce. And based on the objectives of the study, we, for our growth and survival analysis, used only planted white spruce. However, for both yield projection for both models, we included both planted and natural regenerated white spruce. So next important question was about site productivity, and we used Aspen site index and calculated for each plot following the standard gypsy site index curves procedures. We selected at each plot top dBH aspen trees. Then for the zero tree aspen treatment, we used mean installation aspen site index and assigned that site index to the zero tree aspen treatment. Then for the spruce site index, we applied recently developed aspen to spruce site index conversion model. And here are results by installation. What we can see for aspen site index, pretty similar productivity within the younger stand age stands. A little bit more variability within older treatment age 22 stands, and that also reflects to the white spruce site index. We can see similar pattern there. However, when we check the site index by treatment, we also applied the mixed model ANOVA and confirmed that between treatments we found no significant difference in terms of site index for both species and for both treatment ages. And analysis for this study, 3 parts. So first we did the pre-treatment stand condition assessment. Then for post-treatment assessing growth response to thinning treatments, we did separately for aspen and spruce. Then for aspen, we used only dominant aspen trees because the thinning altered the stand aspen density and basal area. So in order to avoid that called chainsaw effect, we selected only dominant aspen trees for the growth and survival analysis. Then analysis was conducted separately for each measurement year for both treatment ages. We use growth parameters for both species: survival rate, height increment, height diameter ratio, diameter increment, and so. And we applied the appropriate statistical analysis that includes mixed modeling in order to account for hierarchy to randomize complete block design, that hierarchical structure of the data, and if applied follow-up with the post hoc multi-comparison test, it found some significant relationships. And the last part was long-term yield projections. For that, we used both Alberta's model, we used latest MGM18, we used Gypsy, and to initialize the projections, we used the latest measurement. That is for the measurement 3 for all 7 installations in younger stands, and 4 installation in older stands that 55 plots at all, and we generated for both no utilization standard applied, and also for the 1510 utilization standards for both species. And we analyzed results from those yield projections. We tested treatment effects on culmination age, density, MAI, volume, using the same approach with mixed model ANOVA, and we calculated culmination age on 3 different ways. So we based the culmination age for culmination of deciduous MAI, then we based on culmination on coniferous MAI and total stand MAI, all with the merchantability criteria in use. So first results from just briefly from pre-treatment measurements. What we wanted to see here, for example, for planted spruce, the darker red color, we can see pretty across the treatment, we can see consistency in terms of stand density, but also in terms of the diameter and the mean height at each plot. We checked for all species, including dominant aspen trees as well. We formally applied the ANOVA test here and confirmed that in terms of initial stand conditions, we found no differences between treatments and any of the treatment ages, and that was important in order to select appropriate statistical approach for the analysis. Then for post-treatment measurement results, first set of results is for survival, and results for aspen are on the left-hand side of the panel, and top graph is stand density. What we can see here, like measurement one, how those desired treatment densities were set at measurement 1. We can see the control plot, which has about double the number of trees than the 5,000 treatment. And then we can see for measurement 2 and measurement 3, we can see the decrease in stand density, of course expected, as a result of self-thinning. Those stands are in the stem exclusion stand successional stage. That was expected. However, the stand density for all other treatments still stay at the same, more or less on the same level. Then we checked survival rate, and then we confirmed that all those 3 treatments, thinning treatments, were not statistically different. They range, the survival rate ranges 90 to 100%, but not statistically different. What we see different statistically here, survival rate for the control plot, and that was in a range around the 60%, and that was confirmed in both treatment ages. Then results for the survival of white spruce, and these results are pretty much straightforward. So we found that no significant effect of aspen thinning on planted white spruce survival. So that was confirmed for both treatment ages, and that is our first big conclusion of these studies, that actually thinning didn't affect spruce survival at all. Then results of aspen growth response to aspen thinning. And here on the left hand side of the panel, we can see the diameter related matrices like DBH, diameter increment, relative diameter increment. And the results shows that there's a delay in response of the diameter to thinning. We can, after the first three years, after the first observed period, we can see some differences, but still not statistically significant. But then after the next 5 years, we can see that in this case, 1000 treatment was significantly different than control plot. Similar relationship was for the older stands, and also we can see for diameter increment clearly that relationship with that diameter increment decreases as aspen density increases. So that is pretty clear results in terms of DBH for the high diameter ratio. That is response to treatment is pretty much similar to diameter, and then we have here the graphs for height and for height increment, but again for those height related matrices, again nothing was significantly, no treatment was significantly different. Again, pretty clear finding here that aspen thinning didn't accelerate height growth. So aspen growth response, and the next set of results for spruce growth response to aspen thinning. So again, first for DBH, we can see that the diameter response of spruce was immediate after the thinning, and that we can see that with time those differences getting larger, and that was case for both treatment ages. Even more, if we check the diameter increment, we can again see that clear relationship, and in some cases, for example, the largest response here was found following complete aspen removal, where diameter increased about 2 to 2.5 times over the first 8 years after treatment. Then spruce growth, height growth response, the relationship is a little bit different. There was a delay of height response after the thinning. So after the first observed period, we see again some differences, but not statistically different. What we can see statistically different is at measurement 3 for younger stands. Then now we have differentiation, where on one side 0 treatment and 1000 treatment was statistically different than 5000 and control plot. So that is interesting result. Again, probably expecting what we expected, because some other studies shows that height delayed in response for spruce. Another interesting finding here is that height increment was lower at measurement 2 in pure spruce than for all other treatments, and that again that was the case for both treatment ages. And then after following next observed period of 5 years, that height increment in pure spruce treatment was higher than all other treatments. So just quickly to summarize this part regarding results on post-treatment measurements, we can say aspen densities had no significant effect in survival of planted spruce. The next, for the aspen, 8 years after thinning, diameter of dominant aspen was increased by thinning, while there was no effect of thinning on aspen height growth. For spruce, height and diameter growth increased with thinning intensity and with time after treatment. And there was a slight adjustment in spruce height growth during the first 3 years after thinning, reflecting a shift in growth allocation to diameter over height for the for the zero aspen density. Now results on yield projections. Again, we used two models. The simulation of the growth of each plot were completed to age 200. Then we use installation site index for both models. Small difference was in terms of birch was included in FGM and removed from the gypsy. Then again, predictions with no utilization standards and 1510 utilization standards. And so a little bit of challenge was for gypsy, how to set to initiate gypsy projections. Gypsy requires 2 of 3 parameters, at least 2 of total age, site index, or top height. And that was easy for Aspen, so we used total age. Those were known variables, total age and site index, except for ingress of Aspen in pure spruce treatment, which happened between the second and third measurement with unknown age. So in that case, we use site index and top height. And actually, challenge was what to do, how to set those projections for white spruce. So we tested actually all combination of those input parameters. First, the site index and age, top height and site index, top height and age. Because challenge was in this case, this specific case, where spruce was growing the first 25 or 30 years under the suppression of overtopped aspen trees. So in that case, the top height or age was irrelevant in this case. For gypsy, we choose to use top height and site index as an input parameters. That kind of makes sense for this analysis, and also that best compares to the MGM predictions. These graphs are for spruce top height predictions. The next basal area adjustment and then percent stocking were optional parameters for the gypsy as well. We then tested again all combination of those input parameters, and in this case we talk about stand MAI. And because we choose to use basal area adjustment again, because it makes sense, this thinning altered the stand density and basal area in this study, and then we, because of that, used the basal area adjustment. However, we did not use percent stocking, and I was not sure how to interpret that variable to our study. So here are results for the yield projections from MGM model, and as I mentioned, we calculated culmination of stand MAI, then culmination of coniferous MAI, culmination of deciduous MAI. So what we can see here, that culmination age is low for, of course, for deciduous MAI in the range of 50 to 55 years. No difference between treatments. And then for the culmination of coniferous, we have increase of those culmination age with increase of aspen, and ranges 95 to around 150 years. So interestingly, for stand culmination of stand MAI, we found no differences between all thinning treatments where we have aspen. So that includes 1,000, 2,500, 5,000, and control plot. We tested, and this was not significantly different, although there's some range from around 73 to 85. And of course, the culmination for pure spruce stand was different in this case. So that's first interesting finding. Then we checked the stand MAI, and then we see for all those data that treatment 1000 reached the highest MAI of 7.2 for the younger treatment age 17. But we also, and that was actually statistically significant than all other treatments. We can see decrease in magnitude of this stand MAI at the time of culmination, but this particular treatment was statistically different. Then we also checked the volume at the time of culmination, maximum stand MAI, and we broken those down to deciduous and coniferous components. And I found this graph particularly very interesting with important results. So I will zoom in now to this plot. What we can see here first regarding the deciduous volume, that actually there's no difference between deciduous volume across all these treatments. We checked that again with the ANOVA test and found no difference in deciduous volume. What we also checked here was in that case deciduous average DBH and merchantable volume per tree. And we can see in this graph, this is for deciduous average DBH. We can see that actually even we have the similar deciduous volume. Average size of the diameter was significantly larger for 1,000 treatment. Even more, if we check deciduous VPT, it's even more obvious that 1,000 treatment reached the higher values. So, and those results were for this younger stands of 1,000 treatment. Another interesting finding here is in terms of the coniferous volume, and again for control treatment, 5,000 treatment and 2,500 treatments, there it was not significantly different, and we can see bump here, which shown to be statistically differently higher coniferous volume in this 1,000 treatment, which appear according to this to be clear winner in terms of this volume predictions. We also try to visualize these differences between treatments, however, using SVS software, but at this scale, we really don't see those differences here, so I will just skip this part. And now next set of results is actually comparison of growth projections for between MGM and gypsy. And first, we can check coniferous top heights here, and we can see that both models show similar projections of spruce top height in pure spruce stand, while some differences between the models increase with increase of aspen density, and that is reflection of MGM growth functions that do cause a reduction in spruce height growth by overtopping accounting competition effects. So that is one comparison in terms of coniferous top height. Then deciduous top height, those two models provide similar prediction of aspen top height until the period of canopy transition, right? At some point, MGM we can see decline in aspen top height as a result of that canopy transition stand stage. And we can see that it starts the earliest at treatment 1,000, and that it starts later for the control treatment plot. That's one thing regarding the deciduous top height. The other is how the ingrowth of aspen was modeled. In some plots, we found aspen ingrowth in pure spruce stands happening between the second and third measurements. However, MGM does not, and we can see different results because MGM does not currently model ingrowth comparing to the gypsy. And next results are for stand MAI. Again, we can see some differences here. For example, treatment 1,000, greatest difference was for treatment 1000, and that shows us again how those two models differently deal with the thinning and aspen and the growth responses after thinning, because the greatest difference was in 1000 treatment, and then with increase of aspen density, that difference getting smaller, and almost over predictions overlap in a control plot. Then for yield projections from deciduous volume, for coniferous volume, and for total stand volume, we again can see some differences here. So first, for gypsy, magnitude of gypsy predictions are related to that basal area adjustment at the time of initialization, and then we can see how that increase with increase of aspen density in treatment. However, MGM is designed to directly model complex multi-species, multi-cohort stands at the tree level, so accounting that effect of competition. As I mentioned before, we found no significantly different maximum of MAI for any of those treatments. So in terms of MGM, that all should be not so statistically different. The other difference was the culmination for deciduous volume for MGM peaks earlier, and after that there's sharp decline, and there's a biggest difference in prediction in older ages between MGM and gypsy, with the aspen density increase. So that's for the deciduous volume. For coniferous volume, now we can see that MGM predicts higher coniferous volume than gypsy, with differences increasing with aspen densities, and again there are more differences in control treatment plot. That one difference. The other again. Culmination of coniferous volume is different for MGM. Actually, for the gypsy shows positive trend in coniferous volume throughout entire 200 years simulations. And finally, for stand volume, again we can see, for example, a control plot. They all pretty much overlap, and some small differences in terms of when aspen density decreases. However, should have in mind that actually those two coniferous and deciduous components were differently modeled by those two growth models. And the last slide for results, just regarding some comparison of some numbers in the time of culmination stand MAI for both gypsy and MGM. For gypsy, we can see with increase of aspen density, decrease of culmination age. Different results for MGM. We can see no significant difference for all treatments except the pure spruce treatment. Then for the stand MAI, we can see maximum stand MAI increase with aspen density increase. Opposite trend was for the MGM with maximum 1000, and then decrease with aspen density increase. Then for total volume, gypsy, all predictions for all treatments were pretty similar, statistically not significantly different. However, we can see the ratio between the deciduous and coniferous now ranging according to that basal area adjustment applied at the time of initialization of the MGM predictions, and results are different. For MGM, we can see that treatment 1000 showed the highest volume, significantly different. We can see that coniferous volume is again significantly different for this treatment, and we also see that there's no difference in terms of aspen volume in those treatments. So now just briefly to point some conclusions that aspen density had no significant effect on survival of planted spruce. Then that 8 years after thinning, diameter of dominant aspen was increased by thinning, while there was no effect of thinning on aspen height growth. Then spruce height and diameter growth increased with thinning intensity and with time after treatment. And finally, yield projections show that heavy pre-commercial aspen thinning, so thinning was done to reduce aspen to 1,000 stems per hectare, in Boreal mixedwood can result in an increase in coniferous merchantable volume without reducing aspen volume at the time of harvest. This also means that light to moderate thinning, reducing density of aspen trees to 2,500 stems or higher, is unlikely to result in gain in either deciduous or coniferous merchantable harvest volume over those of unthinned stems. At the end, I would like just to acknowledge first FGrOW for making creating this great experiment, and for all those mixedwood practice team members. You see the list here, but also would like to acknowledge to some people involved in this project. First, development of study design was led by Gita Grover and Willie Fast. Stacy Bergheim assisted with project development and management. Sharon Meredith provided oversight of the project for many years. And then all contractors and people involved in measurements and helped us with analysis.